So imagine a surgeon, right? Operating entirely remotely, relying on a 4K monitor.
Oh, that is absolutely terrifying if there's any delay.
Exactly. I mean, a lag of even a tenth of a second between their hand moving and the screen actually updating, that could be disastrous.
Yeah, completely unacceptable in that scenario.
Right. So today we're doing a custom deep dive into the technology that, well, eliminates that lag entirely for you.
We're looking at the spec sheet for the ZeeVee ZyPer4K XSE fiber encoder, which is this high-end AV gear you can get via HDTV Supply.
Okay, let's unpack this because, sending video over IP is pretty standard now, but doing it flawlessly at a massive scale is a totally different engineering challenge.
It really is. It requires just an entirely different tier of performance. I mean, we're looking at a device whose primary function is streaming uncompressed 4K video over a 10 gigabit fiber network.
The key word there being uncompressed.
Right. Uncompressed is everything here.
Because, well, traditional video compression is essentially like IKEA furniture, right? You spend all this time and processing power breaking a video feed down into these
Mathematical flat pack boxes.
Yes, exactly. You break it down at the source, and then the display at the other end has to, spend time reassembling it.
And that mathematical assembly just takes precious milliseconds.
Right. But this 10 gigabit fiber connection basically teleports the fully built couch directly into your living room.
I love that analogy.
Yeah.
That teleportation basically strips away all the algorithmic packaging. And the ultimate result of that is zero frame latency.
Which is wild.
It really is. When you don't have to compress and decompress, you eliminate the processing delay entirely. The image hits the display the exact millisecond it happens in real life.
Which, like we said, is non-negotiable for high-stakes live viewing, whether that's a medical procedure or a live sports broadcast.
Exactly. But, speed and quality don't really matter if the signal can't actually reach its destination.
Very true.
And what's fascinating here is the transmission range. This device hits 300 meters on multi-mode fiber, but it pushes a staggering 10 kilometers if you switch to single-mode fiber.
Wait, who actually needs to send a video signal 10 kilometers away?
It sounds like overkill, right?
Yeah. I mean, I know single mode achieves that range because it uses a laser to shoot light straight down a microscopic tunnel.
Right, preventing the signal degradation you get with multi-mode, which bounces light around a wider core.
Right, but 10 kilometers is the size of a small city.
It sounds absurd, I know. Until you realize how that distance connects to the device's scaling capabilities, this encoder supports video walls up to 15 screens wide by 15 screens high.
Oh, wow.
Yeah, that is 225 synchronized displays. And it also handles multi-views of up to 19 different sources on a single screen.
Okay, keeping 225 screens perfectly synced without tearing across a massive physical footprint, that is a serious sync challenge.
Oh, it is the ultimate sync challenge. Imagine wiring a sprawling university campus where a single lecture needs to be broadcast to 10 different buildings simultaneously.
Right, or like a massive sports bar network.
Or a casino floor.
Yeah.
You need thousands of screens to act as one cohesive canvas without a single hiccup in the frame rate.
Okay, but wiring a campus with 225 screens across 10 kilometers introduces a pretty terrifying problem. I mean, anyone could potentially plug into that sprawling network and just intercept a feed.
That is a very valid concern.
So here's where it gets really interesting. How is a footprint that massive actually secured?
Well, the ZeeVee encoder uses AES-128 encryption to protect the video stream itself, alongside HTTP 2.3 to protect copyrighted content. Plus, it's TAA compliant, which hits those strict procurement requirements for government and military applications.
Wait, hold on. If we are passing uncompressed 4K video instantly, doesn't wrapping it in AES-128 encryption require mathematical processing?
You would think so, yeah.
Doesn't that inherently introduce
the exact latency we literally just tried to eliminate?
Yes. Exactly.
It absolutely would if it were software-based encryption. But this is executed at the hardware level.
Oh, gotcha.
Yeah, the encryption and decryption happen inline at network speeds, meaning the data is secured on the fly without sitting in a software buffer. You get the security without sacrificing the zero-frame latency.
That is incredibly smart engineering. And looking through the rest of the spec sheet, there is a brilliant practical feature here for the actual AV installers dealing with hardware at the podium.
The USB-C integration, right?
Yes. There is a single USB-C input that handles the uncompressed 4K video, but it simultaneously provides up to 60 watts of charging power back to the presenter's laptop.
It is such a lifesaver. It completely eliminates cable clutter at the conference table, really streamlining the friction points AV professionals face daily.
No power bricks, no EDID handshake issues with multiple adapters, just one cable. So, what does this all mean for you? Whether you are an AV professional building out a massive entertainment venue or just a tech learner wanting to understand the cutting edge of networking, this device proves that distance and scale no longer have to compromise quality or introduce lag.
Truly, it leaves you wondering if we can push uncompressed 4K video instantly over 10 kilometers to power a 225-screen video wall with absolute zero latency. Are we rapidly approaching a future where digital windows can completely replace reality without the human eye ever noticing the lag?